In this video, I'm going to give you a high-level overview of the workflow of developing Flames-based simulations. Let me start by giving you a high-level overview of Flames itself. As you probably already know, and you may have already seen this slide, Flames is a framework, a model-independent framework for developing custom simulations. And when we say framework, what we mean is that Flames is 100% infrastructure, and it contains no modeling software. So the modeling software is a software that represents the functionality of real-world systems, the systems that are going to be simulated, sensors and tanks and airplanes. The infrastructure software is a software that doesn't represent things that exist in the real world. It's the software that's necessary because it's a simulation. Memory management, graphical user interface, 2D and 3D visualization, etc. We've implemented the infrastructure in such a way that it is completely separate from and independent of the modeling software. Flames also provides the interfaces that are necessary to automatically integrate plugins. That's kind of the magic sauce. This is what allows us to build the framework in a way that is independent of the modeling software. These are like the slots on a motherboard where additional functionality gets plugged into the motherboard. The modeling software is implemented in plugins that are completely separate from and external to the framework. So this is where you have your sensors and your platforms and your missiles and weapon systems and things. They're all implemented outside the framework in plugins. So you create different simulations not by changing the framework. The framework doesn't have to be changed at all. You create different simulations just by creating different sets of plugins to represent the systems that you want to simulate. Now, let's take a look at some of the Flames products and how they relate to the software development workflow. First is the Flames engine. The Flames engine is a set of existing applications that are used to create, execute, visualize, and control Flames scenarios. The main applications are Forge, Fire, and Flash. These applications are already developed. They're included in the Flames engine. So when you're developing a Flames-based simulation, the workflow does not include you developing executable programs. Again, those programs already exist. What you're doing is you're developing plugins that get loaded automatically by these applications when they execute. So where do you get plugins? Well, plugins in binary form are resident in the content items in the Flames store. And this is just an example of a few of the content items in the store. We've got several different content items. The content items include plugins, and then they also include scenarios that are built to demonstrate how the models in those plugins actually work. And they oftentimes include documentation as well. So that's how you get started with Flames. You download the Flames developer, which includes the free trial version of the Flames engine applications. You go to the Flames store and get the content that is interesting to you, and you install that. All that gets installed using the Flames launcher. It's all very easy, all online. And you create a project, and then you start executing the scenarios that come in that content. The plugins that are included in the content items in the Flames store provide a tremendous amount of capability without requiring any software development at all. You may find that the plugins in the Flames store give you all the functionality that you need to satisfy your simulation requirements. But if you don't have everything you need, you can develop your own plugins to allow you to create a Flames-based simulation that is tailored to your specific requirements. And for that, you'll use the Flames developer. Flames developer is free. That is also downloaded from the Flames store. It is you could call it a software development kit if you want, and it's what you use to develop your own custom component plugins. Key thing about it is it uses Microsoft Visual Studio. We don't have our own programming language or our own software integrated development environment. We just use standard industry accepted, very popular tools. And on Windows computers, we use Microsoft Visual Studio. Flames developer includes a base template Visual Studio solution. So that's already included. In fact, you can open that solution right from within the Flames launcher. There's an item icon there. You click on it. It starts Visual Studio Solution. The whole environment is all defined, ready for you to start doing development and for your component plugins to be able to be used as soon as you create them. It also includes, the Flames developer also includes an immense library of functions and all the base classes that you use for developing your custom component classes. It also includes tools that are used to support the development, and you'll learn more about those as you get into the development courses. Just want to mention that the custom classes, these component classes that you're writing, they're developed in C or C++. Those are the programming languages that we use. And again, you'll learn more about that as you get into the software development training videos. So here's the process for creating a plugin. Again, you're using Visual Studio. In your Visual Studio, you'll create projects, and those projects will contain the custom code for your custom component classes. When you compile and link, you'll be compiling and linking with the Flames classes and libraries. And what you're creating with Visual Studio, again, is not an executable. What you're creating is a plugin, and that plugin is actually a Windows Dynamic Link library. So all those plugins are DLLs. So that's what you're creating. You're not building Forge, you're not building Flash, you're not recreating those applications. You're creating plugins. And you can create one or more plugins. Each Visual Studio project will generate one plugin, and you can have multiple Visual Studio projects. So those plugins automatically get put in the right place in the environment that's defined in your launcher project. It's all set up automatically. And when you start your Flames applications from within the launcher, they will automatically load those plugins. So if you've used Forge before, and you've already used some of the components in the Flames store, and you've maybe gone through the user training classes, if you've done that, you'll notice that when Forge starts up, it opens up a status window. So here's just an example of a status window. And if you ever looked at the text in the status window, you'll notice that one of the things it lists is the names of the plugins, the names of the DLLs that it loaded. In this case, it loaded 4 different plugins. So Forge behaves differently depending upon which plugins are loaded. And again, your software that represents the systems that you want to simulate is resident inside those plugins. So what kind of modeling classes, what kind of models can you develop? Well, that's going to be explained in much greater detail in other Flames training videos. In fact, the next training video talks in much more detail about the base classes, but I just want to mention it here. This is the Flames modeling class hierarchy for the base classes. These are the abstract classes that get inherited by specific modeling classes. So right in the middle, you'll see the F-Equipment class and a bunch of subclasses underneath that. FCOM device, data processor, jammer, platforms, munitions, sensors, subsystems, and weapon systems. Those are all the different types of equipment that exist in real-world systems. So when you want to build a set of software that represents the functionality of some real-world system, you'll build a class for its platform, you'll build a class for its sensors, you'll build a class for its weapon system that has those. Another class on this chart is the cognition model. Every player in Flames, we call them units. Every unit in Flames is controlled by software that represents the human that would be controlling that in the real world, the pilot or the tank commander or the gunner or whatever it might be. That human cognition capability is simulated by cognition models. So you write different classes of cognition models. And there's several other classes that are listed here. Again, another Flames training video goes into these classes in detail, and you'll get a chance to learn how to write each of these classes in other Flames training videos. I just wanted to give you an introduction to this. When we talk about component classes, it's classes that inherit and descend from these base classes. Every class that you ever write will be a subclass of one of these classes, every modeling class. So we talked about source code to your custom classes. How do you get that source code? How do you get started? You get the source code from the repositories that are in the Flames Framework organization in GitHub. as we talked about, there's a bunch of different content items in the Flame store. And those content items include component plugins, DLLs. The source code to all the DLLs that are currently in the Flame store is available for free in the Flames GitHub repositories. So you give us your username, your GitHub username, and we will give you access to the Flames Framework repositories. And then you can go to those repositories, and there's a bunch of them, 8 or 9 of them so far. Again, it's the source code to all the different component plugins that are in our store. The GitHub repositories don't include just the source code. They actually include complete Visual Studio projects. So for example, the starter components, there's a bunch of modeling classes in the starter components. In the GitHub repository where that source code is located, it's in the form of a complete Visual Studio project. So you clone that repository and you clone it and put it right into the particular folder within your Flames launcher project, and the Visual Studio that is started from within the launcher knows about that folder, and you can go to that folder and add that project right to your Visual Studio solution. And with just a couple of minutes, you can have all the source code to the starter content loaded in your Visual Studio solution and built to create a plugin that is an exact replica of the plugin that gets downloaded from the Flame store. You'll have the complete source code to that same plugin. This is the way you get started. You go grab the source code from the Flames repositories and you pull it down, you build it, and you get DLLs that look just like the DLLs that come out of our store. Then you can start looking at them and examining that code and learning how to build classes of your own. When you get to the point where you want to create your own class, say you want to model a fixed-wing aircraft. So you look at the Flames fixed-wing aircraft and you decide, yeah, I want to enhance that a little bit, or I want to change something about it. You have the source code and you can go change it. What we recommend you doing, you can just change it directly, but we also recommend that you use a tool in Flames that will generate a brand new fixed-wing aircraft or a brand new copy of whatever it is that you want to create from one of the Flames existing classes. So you pick the class, you give it a new name, it creates a new source code. You go to your Visual Studio project, you add that source code to your project, you hit build, it will build right away, and then you can go in and start modifying that copy. And that's exactly how we do software development here at Turnitin. You never start building a Flames class from scratch. You just pick the class that is in the source code repositories that is closest to the class that you want to develop, and you make a copy of it. So you're starting with code that works, that fully integrates into Flames properly, and then you start making changes to it. So that process of being able to start from working classes also saves a tremendous amount of time when you're doing your software development. This completes my overview of the workflow of developing Flames-based simulations. You'll learn a lot more details about how to do this by going through the rest of the Flames training videos. Thank you for watching. Thank you for your interest in Flames, and thank you for your interest in building your own custom Flames-based simulations.